Hello and welcome to helpyourmath.com. In this video, we are going to have an introduction to conjugates and find the common types seen in mathematics. First, what is a conjugate? So a conjugate is generally something dealing with a two-term expression. A conjugate is when we change the sign of one of the terms of a two-term expression. So we change one of the terms of a two-term expression. That's what a conjugate is. So it's also a two-term expression. For example, the conjugates of 5 minus 7, okay, so we're going to change one of the signs of the term. So we're going to change that minus to a plus. We could have 5 plus 7 is one conjugate of 5 minus 7. The other one would be if we change the 5 to a minus 5. So minus 5 minus 7 would also be a conjugate of 5 minus 7. Or if we have x plus 6, one of the conjugates of x plus 6 would be if we change that plus to a minus and make it x minus 6. Or if we just change that to a minus x plus 6. These are most commonly seen, so usually we just change the sign that's in between the two, whether it's an addition sign or a subtraction sign, but you can do these too, those are perfectly fine. One thing that's important to note is that a conjugate is not the same thing as the opposite of an expression. A conjugate is when we change one of the signs. So one conjugate of x plus 6 is x minus 6. The opposite of x plus 6 is when we negate both, when we change the signs of both, negative x minus 6. These things are not the same. So that's why they're not called the same word, because one's an opposite, we change all the signs. One's a conjugate, we change the sign usually between, but we change one of the terms, the signs of one of the terms. So when do we use conjugates in mathematics? Well, conjugates have a very cool feature about them when we multiply. If we multiply, so one example we saw was x plus 6, and we multiply it to its conjugate, one of its conjugates, x minus 6. Let's see what happens. We can use the distribution property, or we can FOIL. This would be x squared if we multiply those first together, minus 6x, and then we have our middles, plus 6x, and then we have 6 times negative 6 minus 36. Well, here's the cool thing. This and this are opposites, and those cancel each other out, leaving us with just that first term, the first term and the last term. So we get x squared minus 36. The middle terms cancel, and the middle terms are going to cancel no matter what with those conjugates, right? Because whatever is going to happen, we have one case that's negative and one case that's positive. So the middle terms will cancel out. How cool is that? Okay. Why do we care? I know you're wondering that. Well, when we work with fractions, mathematics textbooks, and therefore your instructor, are particular about denominators. They should be single, rational, real numbers. Where do we have issues with this? Well, there are two very common types of denominators that we're going to have issues with. One is if we have a two-term denominator involving radicals. So for example, if we have the square root of 3 plus 2 divided by the square root of 3 minus 7. This is no bueno. Now, why is that no good? Because a long time ago, way back before there were calculators, we would have to come up with some idea like, what is this number? The square root of 3 plus 2 over the square root of 3 minus 7, where is that number on a number line? Is it between 0 and 1, 1 and 2? It looks like it might be negative, so maybe it's going to be between negative 1 and negative 2. We don't know. And before calculators, we would have to do this by hand. It's a lot easier to approximate a number that has a single rational denominator than one that has a really strange radical in its denominator. The other time, and for the same reason, is two-term denominators with imaginary numbers. So if we have something like, see, no good. Look at that, it just popped up. If we have 5 minus 6i divided by 7 plus 4i. This denominator, no good. We can't really kind of get an idea of what this number is because we have a complex denominator. So that one's also not great. What can we do about it? Remember what that secret was? Multiplication. If you multiply a number to its conjugate, those middle terms will cancel, leaving you with the first term, which is usually the normal one, normal being rational. And when you multiply the second two, that usually does something with the radical or the imaginary part to clear it out. So if we multiply two conjugates to each other, the middle terms will cancel 100% of the time. Hooray! The radicals will vanish. The imaginary numbers will disappear. Only the real parts remain. So for example, what we're going to do is we're going to multiply this to one of its conjugates, and then we're going to see what we get. So if we take this and multiply it to its conjugate, we should end up with some real non-radical number. What's the conjugate of the square root of 3 plus 5? The square root of 3 minus 5. When we multiply the square root of 3 times the square root of 3, that would be the square root of 9, and the square root of 9 is 3. Here we get minus 5 times the radical 3. Here we get plus 5 times radical 3. And 5 times negative 5 is minus 25. So look at this. There go the radicals. What are we left with? 3 minus 25, which is negative 22, a single rational number. Let's try it one more time, because you might be thinking, wait a minute, that 5 wasn't under a radical. Surely if there's two radicals, it's not going to work. Let's find out. So we're going to take the square root of 6 minus the square root of 11. We're going to multiply it to its conjugate. That would be the square root of 6 plus the square root of 11. And let's see what happens. Root 6 times root 6 is the square root of 36, which is 6. Then here we have plus the square root of 6 times the square root of 11 would be the square root of 66. Here we have minus the square root of 11 times 6 would be minus root 66. And then we have minus 11, square root of 11 times the square root of 11. That's minus the square root of 121, which is 11. Oh my goodness, there go the radicals, leaving behind minus 5, a real rational number. Isn't that exciting? Okay, let's look at the imaginary numbers. Let's see if this also works for our imaginary numbers. If we multiply this to its conjugate, we're going to leave that negative 7 alone. We're going to keep it negative 7, change this to plus 4i. And we get negative 7 times negative 7 is positive 49. Negative 7 times 4i would be minus 28i. So that was this and this. Then we have minus 4i times negative 7. Negative times negative is positive. That would be 28i. Negative 4i plus 4i, this is going to be minus 16i squared. Okay, so these canceled. You might be saying to yourself, wait a minute, there's still an I squared, but I squared is a real number. I squared is negative 1. So this ends up becoming 49 minus 16 times negative 1. Those are two negatives, so this becomes plus 16, and 49 plus 16 is 65. There's a real, rational, single number. We'll try it one more time just to verify. 8 plus 6i, so we're going to multiply it to its complex conjugate, which would be 8 minus 6i, and we get 8 times 8 is 64. 8 times minus 6i is minus 48i. 6i times 8 is positive 48i. Minus 6i times minus 6i would be minus 36i squared. These cancel. This becomes negative 1. We have negative 36 times negative 1, so we end up with 64 plus 36, which is the beautiful, real, single, non-radical 100. These have been examples of finding conjugates and why we want to find the conjugates of numbers in mathematics. Thank you for stopping.